This is part 5 of section 1.3. We're going to talk about the vertical line test and graphs of functions. So now we're going to be talking about how you look at a picture of a relation and decide whether or not it is a function. And it will tie into those pictures I drew on those first problems where we were talking about functions. Okay? The vertical line test says if no vertical line intersects the graph of a relation at more than one point, then the graph of a relation is the graph of a function. Some teachers call this the pencil test, okay? And what you do is you imagine vertical lines passing through, and it's okay if the vertical line doesn't hit your graph, that's fine. It's okay if your vertical line hits in one point, but if it hits in more than one point, you've got a problem. Hits there, it hits there. This is not a function. If you think about this, if you're thinking about the ordered pairs here, you would have the same x value. So like maybe that's 1, -3, and this is 1, +3. It had the same x value, and if you remember, we cannot have repeated x values. That makes it not a function. So this ellipse, not a function because it doesn't pass a vertical line test. Whereas here, this parabola-like shape, no matter how many vertical lines you put through it, you never hit more than once. So this one passes the vertical line test. It is a function. When we were talking about these first problems, I said that the absolute value here, that graph would look like this. You hit more than once, not a function. This one is a circle. You hit more than once, not a function. Here, this never hits more than once, so it is a function. I just realized I didn't write that. Okay? So once we get to where we can look at things and we have, even if we don't know the exact shape of the graph, when we get to where we can look at it and have a decent idea of its shape, we'll know more quickly whether or not we are dealing with a function. Okay, so now how can we use our graphs to get information from them? Okay, and this actually ends up being a pretty important concept in calculus as well. We need to really understand what our graphs are telling us. If nothing else, you need to wrap around your brain around the fact that I'm not making you do graphs because I'm going to be picky about pictures that you draw. These things have meaning, they are real, we have to understand what they are doing for us, okay? So in these problems, we're asked to use the given graph to find the indicated function values. Now this is telling us to use the function g, which we're not given the formula for, but we don't need, plug in -2 for x, and what answer do we get? Well, if I plug in -2 for x, well, right here they have -2 for x. What value did I get? Well, my y value is 5, so this is 5. It's that simple. Okay. G of 1. If I plug in 1 for x, well, they did that right here. When they plugged in 1 for x, they got -4. So that is -4. Here, G of 3. If I plug in 3 for x, which they did right here, they got 0 for y, so this is 0. Okay, and then G of 4, plug in 4 for x, they did that right here, and they got 5, so that would be 5 as well. Okay, just reading the information off of the graph. Shouldn't be that difficult. Okay, so now let's use this graph to find the domain and the range of the function. Now, you can make this as confusing or as easy as you like, okay? All this is telling us, all we're asking basically is for the location of our graph. If I am giving you the entire world of a two-dimensional graph, these go off to infinity in all directions. How can I tell you where to find the actual small picture of the graph because it only exists in a small little area? Okay. Basically, you want to tell for your domain. What is the smallest x value represented? And what's the largest x value represented? So on left, right, how far left does it go? This is as far left as it goes. How far right does it go? Over to here. This is as far left. This is as far right. What is the x value here? 1, 2, 3, 4. So that's a -4 there. And what is it here? 1, 2, 3, 4. That's a 4 there. So the smallest x value is -4. The largest x value is +4. It does exist at both, so we use brackets. This just tells me if you're going to look for the graph and I give you like this giant infinitely large grid, go look between the x values -4 and +4 and it's somewhere in there. Okay? Now basically we do the same thing for y. So for our range, we're doing the same thing for our y values. What is the smallest y value we have? Well, it goes all the way down to here. That's our smallest value, which y value, which is 1, 2, 3. So that's -3. The largest y value, well, that's going to be here as well. Okay, and that y value is +3. So where is it located if I'm looking on the y-axis? Well, my graph is located between -4 and 4 on the x and between -3 and +3 on the y. And again, it exists at both of those points, so we use brackets.